Hello Year 10s, and indeed anybody else I show this to over the course of my teaching career. I hope that you're doing well. Today, because you haven't had the chance to do this in the lab yourself yet, I'm going to show you how you'd go about measuring the rate of reaction in the lab and calculating rate of reaction from the graph that you would produce. So we have some equipment here that I've shown you in class and also some different reactants I'm going to introduce you to now. I've weighed out 3 grams of calcium carbonate, marble chips, in each of these little boats here. I have a gas syringe. Okay, at the moment you can see there is 0 centimeters cubed in this gas syringe, but if I pull this back, you can measure exactly how much gas is in there. We'll reset it to 0. I have 2 conical flasks, so called because they're shaped like a cone. They have this narrow neck at the top to prevent liquid from jumping out if you're mixing anything, or if you've got a reaction where that could potentially happen. I have 2 measuring cylinders, each with exactly 20 centimeters cubed, or 20 milliliters of acid measured in there. I've used the meniscus, which is the bottom of that almost bubble at the top, to line that up with the 20 centimeters cubed mark. 2 different concentrations of acids, 0.5 molar and 1 molar. So obviously the 1 molar there is twice as concentrated. I've already sketched out my results tables. You can always do this when you're doing an investigation. Sketch your results table out first, because you know how often you're measuring something, or you know what your independent variable is if that goes here, and then the next column you can fill it out as you go. Okay, so what I'm going to do is I'm going to take the 1 molar acid, I'm going to pour it into the conical flask, and then I'm going to simultaneously do 3 things, which is hard. I should have got a friend for this, but sadly maybe I've got no friends. I'm going to try to pour this calcium carbonate into here and then place this bung in the top here so that instantly the delivery tube can start collecting that gas and it can go up into the gas syringe. That is my plan, that is my hope. I'm just going to place these conical flasks over here so that hopefully that should be not in a position where it's going to fall over. At the same time, I'm going to start my stopwatch. So I'm going to do those 3 things at the same time. Let's just make sure this is going to fit in here without the conical flask falling over. It is. Wonderful. Okay, let's give it a go. So, calcium carbonate in, bung in, stop, stopwatch. There we go. Not perfect, but it'll do. You can see the gas syringe is already starting to collect that gas. At 10 seconds, there we go, we're at 35 it was. 35 centimeters cubed goes there. At 20 seconds, we're at 50 centimeters cubed. At 30 seconds, we are at 65. At 40 seconds, we're at 70. Notice how we didn't start it at the very beginning, because at 0 it should be 0. At 50 seconds, we're maybe at 83. There. At 60 seconds, we're at about 87. And we'll do it at 70 seconds as well. Just 91. Okay, so that's the first reaction done. That was for, just to make a note on here so I don't forget, 1 molar hydrochloric acid. Now let's try it with 0.5. 0.5 molar here, ready to go. So, calcium carbonate in, bung in, start stopwatch. Of course, it starts at 0 volume collected at 0 seconds. And by the time it gets to 10 seconds, we have, it was at 5 centimeters cubed produced. 20 seconds, we're up to 15. At 30 seconds, we're up to 21. At 40 seconds, we're up to 29. Okay, I'll continue getting results for you for this one.